Hello and welcome. In this video we're going to take a look at how we can add multi-tenancy to an ASP.NET Core 6 application. Now multi-tenancy enables a single application to be used by multiple tenants or customers. So you can have one single application and then you can have multiple different customers using that same application instance. In order to add multi-tenancy to our ASP.NET Core 6 application, we're going to be using the Finbuckle multi-tenant NuGet packages. So you can see over here on the left-hand side, I've created a new empty application. You'll notice that our program C# file simply contains a single root that returns the text hello world. And what we're going to do is we're going to add multi-tenancy support into this application so that it could be used by multiple different tenants or customers. So the first thing that we are going to want to do is install the Finbuckle multi-tenant NuGet packages. So what I'm going to do is come down here to the NuGet window, search for multi-tenant, and you can see here we have Finbuckle multi-tenant and Finbuckle multi-tenant ASP.NET Core. I'm going to go on ahead and install both of these packages, like so, making sure that they are both the same version. It's important that they are both the same version. And now what I'm going to do is add in some tenant configuration to app settings. For the purposes of this sample, I'm going to be storing the tenant configuration in app settings as just static JSON configuration. However, you can extend that to get tenant configuration from other sources, for example, a database, or you can store the configuration in memory. But as I say, for the purposes of keeping things simple in this sample, I'm going to be using the app settings file to store that configuration. So if I open up the app settings.development.json, I'm going to add in a block here called Finbuckle, like so, and then I'm going to add in a block called multi-tenant, and then stores, and then configuration store, like so. Configuration store will have a property called tenants, and tenants here is going to be a list of our tenants. What I'm going to do is I'm going to create a couple of tenants. It's going to have tenant 1 and tenant 2. And what I am going to do is use a generated ID like so for tenant 1. So you can see here we have an ID for tenant 1, which is just a straightforward new GUID. I've then got the identifier, which is 1, and then the name of the tenant, which I'm just calling tenant 1. And then what I'll do is do the same thing again, but for a second tenant. So you can see here we have an identifier 2 and the name tenant 2. Now the way that I'm going to set up these tenants is I'm going to resolve them by the host name. So in the browser, I'm going to set up the configuration such that you can go to 1.example.local for tenant 1 and 2.example.local for tenant 2. And that's why the identifier there is 1 and 2 for tenant 1 and tenant 2 respectively. And I'll come back to how those are wired up to the multi-tenant middleware in just a moment. So that's our tenant configuration in our app settings file. As I say, you can store that configuration in a database or in memory, but for the purposes of this sample, in order to keep it straightforward, we're just going to store that in our app settings configuration. Now what we're going to do is come back into our program.c# file, and in between our builder and app, we're going to say builder.services.add multi-tenant. We're going to use the type tenant info, which comes out of the box with the Finbuckle multi-tenant NuGet package. You can extend tenant info in order to include additional custom properties, but for now we will keep using the built-in tenant info type from the package. And then what we're going to do is we're going to say with host strategy and then with configuration store. So to break down what this is doing, add multi-tenant is adding in all of the core multi-tenant services into our application. And then the host strategy, if we hover over that, you can see here the comment. It adds and configures a host strategy with template __ tenant __ dot asterisk to the application. And what that is doing is it's going to be resolving the tenant identifier from the bottom level domain. So in this instance, you'll see we have this tenant wildcard, if you like, dot, and then asterisk. And so this tenant is going to be substituted with the actual tenant value, and then the asterisk can be just anything on the end. So as I mentioned earlier, we're going to use 1.example.local and then 2.example.local, which means that the tenant in this case would be 1 and 2, because the asterisk is then going to be example.local. So tenant is 1 dot and then the asterisk example.local. And that's why in the configuration the identifier is 1 and 2, because in the browser we would navigate to 1.example.local, and it picks out the 1, the bottom level of the host name, as the tenant identifier, which is this tenant wildcard or substitution value, whatever you want to call it. It's important to note that you can customize the host strategy, so you can pass in the template if you want to customize it. So if you wanted to have the entire host name as the tenant identifier, then you could simply pass in the string __ tenant __ like so, and that will override the built-in default template, and this will essentially resolve the identifier to be the entire host name. However, for the purposes of our sample, we will use the default template, which, as I say, just provides the bottom level of the domain as the tenant identifier. In this sample, 1 and 2 for tenant 1 and tenant 2 respectively. The configuration store then sets up the multi-tenant services to use the default I configuration, and it looks for a section called finbuckle multi-tenant stores configuration store, and that corresponds with the nested structure that we have set up in our app settings.development.json. Again, to note, it uses the default I configuration, and of course there are multiple configuration providers, not just app settings.json. It also picks up things like environment variables, etc. So with the configuration store, you can store that data in app settings.json, or you could store in things like environment variables or any other configuration provider that is built in to ASP.NET Core. So that's our multi-tenant services added to our application. And what we can do now is add the multi-tenant middleware into our startup. So in order to do that, between the builder.build and the app.mapget, we can simply say app.use multitenant, and that adds in the multi-tenant middleware into our application. Now you'll notice that we have this boilerplate mapget root, which simply returns the string hello world. Now what we're going to do is we're going to update that to return the name of the tenant. So what we're going to do inside the handler callback, we're going to add in the from services attribute like so. And then what we're going to do is we're going to say I multi-tenant context accessor, and this is going to be of type tenant info, and then we'll call that multi-tenant context accessor. We can import that using statement into our file, and notice how the multi-tenant context accessor has the same tenant info type as the one that we registered when we added multi-tenant to our application's services. It's important to note here, if you extended that tenant info type to add extra custom properties, then make sure you specify the same type here where you have the multi-tenant context accessor. Otherwise it won't be able to find this service from the dependency injection. So then what we will do is we will replace the world in hello world, like so. And what we'll do is we'll say multi-tenant context accessor dot multi-tenant context dot tenant info dot name. And this will return us the name of the current tenant who sent the request. So that is our application set up with the multi-tenant configuration in our app settings for tenant 1 and tenant 2. We've then added in the multi-tenant services to our application. We're using the multi-tenant middleware in order to set up the tenant in those services. And then finally, we've updated our map get route to have the multi-tenant context accessor injected into the handler. And the handler then returns hello plus the name of the tenant. And the name of the tenant is automatically resolved from the tenant name in our app settings configuration for each tenant. So what we're going to do now is we are going to add in the application service to our Docker Compose file. So what I have here is an empty Docker Compose file like so. And what I'm going to do is create a block for services. And inside here, I'm going to add in our application. So what I'm going to do is create a service for the application. This is then going to build our application. The context is going to be the root directory of the solution. And the Docker file is going to be in the application folder and then Docker file like so. And then what I'm going to do is I'm going to specify the environment variables like so. And what we're going to do is we're going to say ASP.NET Core underscore environment, and that is going to equal development like so. And then what we're going to do is we're going to add in another environment variable called virtual underscore host, and that is going to be *example.local. And that means that any requests that go to any domain .example.local will be routed through to this container. For example, any request going to 1.example.local or 2.example.local will automatically be routed through to this application. Now, in order to configure that routing, we are going to add in a proxy service or proxy container into our Docker Compose. Now this proxy is going to use the Nginx proxy image. So we will specify the image there of Nginx proxy /Nginx proxy. And then what we're going to do is we're going to specify the ports. And this is going to map port 80 and also port 443. Those are the default HTTP and HTTPS ports. And then what we're going to do is we are going to add in a few volumes. So the first volume is going to mount our docker.sock into the Nginx proxy container. And then we're going to add in two more volumes. We're going to add in one for our public certificate, and we're going to add in one more for our private key. And this will enable the Nginx proxy to accept traffic over HTTPS using a self-signed SSL certificate. And we will generate that in just a moment. And that's going to be the public certificate, example.local.crt, and the private key, example.local.key. It's important that these files are named in order to match the virtual hosts. So you'll notice here that we have a wildcard virtual host that has a wildcard.example.local, and that means that any requests to this container will be in the browser as, for example, 1.example.local or 2.example.local, and those will automatically be picked up using the example.local.crt certificate and example.local.key private key. So that's how you can set up wildcard hosts with wildcard SSL certificates. You essentially just name the public certificate and private key files example.local in order to match whatever you've got set up as the non-wildcard part of the virtual host. So that is our Docker Compose file with our application service and our proxy service. And now what we're going to do is we're going to generate that self-signed certificate. So if you open up a terminal like so, and what we are going to do is we're going to run a command here to generate a private key and public certificate with a subject of common name localhost, and we've also got the subject alt name localhost and also the wildcard *.example.local. And this will allow the certificate to accept any HTTPS traffic that is going to any domain .example.local. In our sample, that will be 1.example.local and 2.example.local. So if I run that command like so, that has generated us our certificate and key. And now what I'm going to do is I'm going to export that public certificate and private key into a PFX file. I'll enter an export password like so. I'll just use the password for the purposes of this sample. That's now generated a PFX file. And what I'm going to do now is I'm going to import that PFX file into the certificate store of Windows, which will allow the certificate to be trusted so that I won't get any warnings in the browser. So what I'll do is I'll enter the password like so. You can see I've then got a prompt to import that certificate into the Windows certificate store. I'm simply going to hit yes, and we can see that the certificate, the PFX file, has been successfully imported into the Windows certificate store. What I'm going to do is just move those files into the root of the solution, like so. So now they're at the same level of the Docker Compose file, which means that these relative paths will work as intended. And now what we can do is we can run Docker Compose up in order to build and run our two services. So what I'm going to do is I'm going to run this Docker Compose file like so. And this will automatically build our application. You'll notice that we have our application running, listening on port 80. And then we also have our proxy set up and listening for connections. Now you'll notice that our application is only listening on port 80 and not port 443. And that's because we use the Nginx proxy to handle the SSL offloading. So what will happen is we will connect from our browser to the Nginx proxy container using HTTPS over port 443. And the Nginx proxy will then offload that SSL connection, and it will proxy downstream to our application container using port 80. So all of the traffic over the internet from our browser to the Nginx proxy will be over port 443, but then the internal traffic within the Docker Compose bridge network, that will take place over port 80. And that is what the SSL offloading is doing by default in the Nginx proxy. You can set up the applications to serve traffic over port 443 over HTTPS. However, there's a bit of an extra configuration that you need to add into the proxy and into the environment variables for each application in order to do so. But to keep things straightforward, and given that the Docker Compose network is a bridge network and so it's entirely internal, we will use SSL offloading to offload the HTTPS connection at the proxy level, so then any downstream requests from the proxy to the service application container is then just handled over port 80. As I say, because that is just an internal internal network traffic in the Docker Compose bridge network, so it's not exposed to the external internet. So now that we have our application and our proxy running, we can now open up our web browser and connect to our application. So what we are going to do, if I just make sure to close these windows down so that the changes in the Windows certificate store take effect. If I open up a new incognito window like so, just pop open into a guest mode. And then what I'm going to do is go to https 1.example.local and notice that I have the message hello tenant 1. So we can see here in our proxy that we have the request routed. We have a 200 here. So we can see that request to 1.example.local, and we can see that was successfully routed down into our application. And notice the message hello tenant 1. We can therefore assert in our startup that we successfully hit this route handler because we've got the message hello and then we've got the name of the tenant. You'll recall from our configuration that tenant 1 is called tenant 1. The identifier here 1 corresponding to the 1 that's here in the host name in the browser. And that's because we set up the host strategy, you'll remember, to use the default template, which simply returns the bottom level of the domain. In this instance, that's just the value of 1, and that then maps to the identifier 1 here in our configuration, which means it's then returning the name tenant 1 inside our multi-tenant context tenant info. If I were to change that in the browser to 2.example.local, then notice that updates to be hello tenant 2. So that's shown you how you can configure an ASP.NET Core application to have multi-tenant support, and that means that you can have a single application running inside, in our case, a single container, but that single application can be used by multiple tenants or multiple customers. And we've discerned the different tenants in the browser using the host strategy. So we've simply said 1.example.local is tenant 1, and then 2.example.local is tenant 2. And that's how our application distinguishes between the different tenants. As I say, we've got one single application running in a container, but it can distinguish or determine between multiple different tenants. And we've configured it to use the host name to do that. But there are other strategies available in the Finbuckle multi-tenant package. For example, you can use a particular header. For example, you might have the origin header or some other header in the request in order to determine the tenant. As I say, we've configured it to use the host strategy with the default template like so. We've then used the configuration store in order to store the tenant configuration, and we've put that into our app settings.json file. But again, you can move that into a memory list in memory, or you could store that in a database using Entity Framework Core, for example. We've then added in the multi-tenant middleware to our application, and then we've updated the boilerplate map.get route handler to have the multi-tenant context accessor injected into it. And we then use that multi-tenant context accessor to access the current tenant name in order to return the tenant name in the response back to the browser. We've then set up our Docker Compose file to have our application and also a proxy. So we've configured our application to serve requests over HTTP, and then we've configured the proxy to serve requests over both HTTP and HTTPS. The proxy then has the example.local public certificate and private key mounted into the proxy container, and that means that the Nginx proxy container will automatically pick up those certificates and use those example.local SSL self-signed certificate to protect network requests from our browser when we go to either 1.example.local or 2.example.local. You'll notice that the connection is secure, and the Nginx proxy container then offloads that SSL connection, so it proxies downstream on port 80 to the internal application container on the Docker Compose bridge network. So as I say, that's shown you how you can simply add multi-tenancy support into an ASP.NET Core application. I hope you found this video useful. Thank you very much for watching, and I'll see you next time.